So today is 28 May and just Saturday. Now, before azeotrope, the discussion of azeotrope should always start with distillation. Distillation is the reason why we learn about azeotrope. Acha, tell me, how many of you remember distillation? How many of you remember distillation? किसी को नहीं याद? अरे ऐसे नहीं होगा ना. How many of you remember this word? Aisha remembers this word. Okay. How many of you? Krishna remembers this word. Just asking about the word distillation. कुछ तो idea होगा ना उसके बारे में. We can discuss it then. Okay. Akshay, tell me. Distillation क्या याद आ रहा है इससे? What do you remember about distillation?
Like removing the impurities from a liquid.
Removing impurities. So some of the crux word that you can remember is purification. Okay.
Yes.
And how do we purify something? How do we purify? एक तो one method is that you can filter. Filtration होता है क्या distillation में? Do we filter something? Filter का use करते हैं क्या? Yes or no? Krishna, tell me.
No, sir, we don't use filter paper, but I think we heat the liquid and then cool it down to separate
heat and cool. ठीक है. So that means like why do we heat? In order to boil it, right?
Yes, sir.
Boil करना जरूरी है ना? So we have come across. So all of you agree with these things, yeah? These are the words that come into your mind when you hear this word distillation, yes or no? All of you agree?
Yes.
Yes, Mansi, Nidra, Kulsum?
Yes, sir.
Okay. Now, we boil things, right? We boil things. So for example, if I have A liquid and there is another liquid which is B, don't write anything, just listen. A liquid and B liquid. When we are boiling something, then we have to know its boiling point. So boiling point is also important. Let us suppose this is having a boiling point of 100 degrees Celsius and B is having boiling point of 200 degrees Celsius. Okay, 200 degrees Celsius. Now, when we start to heat the solution, what will happen? The temperature will increase, right? The temperature will increase. The temperature will go 30 degree, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree. And at 100 degree, what will happen? And at 100 degree, A will start to boil. Correct? Now, when A is boiling, will the temperature still rise? Yes or no? Tell me.
No, sir.
No, no. Why? Why not? The temperature will be 100 degrees Celsius constant. It will not rise. Why?
And the energy will be used for state change.
Correct. Very good. Latent heat of vaporization, right? Whatever extra heat we are giving, it will be used to convert liquid to vapor. It will use to convert liquid to vapor. Now, we are waiting. Okay, fine. 100 degrees Celsius, 100 degrees Celsius. After 3 and 4 minutes, what do we see? We see that the temperature is starting to rise again. Temperature is starting to rise 110, 120, 30, and so on. Now, as soon as the temperature start to rise, what we can conclude, the indication is the temperature is starting to rise, and what we can conclude from that, we can conclude that all the A has been converted to vapor. Yes or no? Please tell me. Yes, Kulsum, Mansi, Nida, right? All of the A has converted to vapor. All of the A has converted to vapor, and this is done. Now the distillation is done, right? What we can do, we can separate out the beaker which is collecting A, and which is collecting A because A has vaporized first and then it has cooled down and then liquefied. Now, the most important thing is that whenever we want to separate anything by this method of distillation, there should be a difference in the boiling point of both the liquids. Yes or no? There should be a difference in the boiling point, right? This is the principle of distillation, right? So distillation is based on what? It is based on the difference in boiling points, difference in boiling points. Now, if you remember the last class, we saw a mixture in which we had acetone and we had chloroform. We saw that acetone is what? It is polar. Chloroform is also what? It is also polar. Now, when we mix acetone and chloroform, what happens? There is hydrogen bond formation. Do you guys remember this from the last class, from Sunday's class? Yes or no? Please
Yes, sir.
Yes, sir.
Right? Now tell me. Acetone is polar, so it will have its own boiling point. This boiling point will be dependent on the polarity, right? Dipole moment only. It depends on the intermolecular force of attraction, which is dipole-dipole interaction. Similarly, chloroform will also have a boiling point, which will also depend on the dipole-dipole interaction of chloroform molecules, also chloroform molecules. So what is happening? Acetone depends on, it has a boiling point, it depends on the dipole-dipole interaction. Chloroform, it depends on Chloroform's boiling point depends on dipole-dipole interaction. But the solution that we have, its boiling point will depend on what? Tell me. Its boiling point will depend on. Its boiling point will depend on what is the intermolecular force of attraction in the solution. What is the intermolecular force of attraction in the solution? Tell me. What is the intermolecular force of attraction? Yeah.
Bond.
Hydrogen bonding, right? All of you agree? Yes or no? Hamza, Hiba, Kulsum, Mansi.
Yes, sir.
Yes, sir.
Right? What is the? Tell me. What is the intermolecular force of attraction in solution?
Hydrogen bond.
Hydrogen bonding. And in the components, what is the intermolecular force of attraction in the components? Components में क्या है? Dipole, right? Yes or no?
Yes, sir.
What is the intermolecular force of attraction in the components?
Dipole to dipole.
Dipole interaction. Which is higher? Hydrogen bonding or dipole? Which intermolecular force of attraction is higher or greater? Yes, Mansi. tell me.
Dipole.
Yes. Anyone else? Krishna, Hamza. What do
So
you think?
dipole.
हाँ अक्षय आपको हमने सुना. What about others? Mansi.
It's hydrogen. Not sure.
Sure. Okay, Krishna.
Sir, dipole bond. Dipole
Okay,
to dipole.
Hamza. Which is
Sir,
higher?
hydrogen
Which
bonding.
bonding? अच्छा. So you can look at your notes ना. कल की क्लास में देखिए acetone और chloroform वाले में we would have written some notes, right? Can you please read that? Go to last class. There you will see acetone and chloroform. Negative deviation, right? So tell me, क्या हो रहा है हाइड्रोजन बॉन्डिंग होने से? इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन इज इंक्रीजिंग या डिक्रीजिंग? Intermolecular force of attraction increasing ना? All of you saw that? Yes or no? Krishna and Akshay,
Yes, sir.
है ना? ठीक है. So hydrogen bonding, it has a higher magnitude of attraction. Than polar. That means the solution will have higher boiling point, because if the attraction is higher, that means we have to give more and more energy, more and more temperature, more and more heat in order to boil it. So the solution will have higher boiling point. Kulsum and Nida, आप लोग की आवाज नहीं आ रही, समझ में आ रहा है? Yes or no? Please tell me. Yes, Kulsum. Yes. Okay. You got this point? Yes or no?
Yes, sir.
What about others? Krishna, Hamza,
Yes, sir.
Akshay. Okay. Higher boiling point. One more thing is very important. That this boiling point will be of solution. And this solution will have only one unique boiling point, which will only depend on the hydrogen bonding. It does not care what is the boiling point of acetone, rather what is the boiling point of chloroform also. It does not care what is the boiling point of acetone and what is the boiling point of chloroform, because acetone is polar, chloroform is polar, but our solution has hydrogen bonding, and that hydrogen bonding determines the boiling point. That is why it will have one unique boiling point. And once it has a one unique boiling point, what will happen? This mixture cannot be distilled. Why it cannot be distilled? Because it will just boil. Let us, for example, say acetone has a boiling point of what we can say 80 degrees Celsius, and chloroform has a boiling point of let us say 75 degrees Celsius. Okay, 75 degrees Celsius. Now, our solution that we have made for acetone and chloroform, it will have a boiling point which is higher than 80 and higher than 75. It will be, let us suppose it will be how much? 85 degrees Celsius. It is 85 degrees Celsius. Now, obviously, when we reach 80 degrees Celsius, nothing will happen in the solution, because in the solution, the intermolecular force of attraction, that is hydrogen bonding, it will boil only at 85 degrees Celsius. Okay, that is why what will happen? This will not be distilled. This cannot be distilled. This solution, which is of acetone and chloroform, it cannot be distilled. You got my point? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Now these solutions which cannot be distilled or which boil at a constant temperature, these are known as azeotrope. So please write the topic. Azeotropes. So what are azeotropes? What are azeotropes? Azeotropes are mixtures that boil at a constant temperature. You know, azeotropes, these are also known as AKA constant boiling mixtures or solutions. On distillation, the components are not separated. Rather, the vapor has same composition. That means the vapor are also having same composition. The vapors are also mixtures only. Same composition. Okay. Now, azeotropes are of two types. Azeotropes are of two types. So by the way, Hiba, what is going on in your class? Yes, Hiba. Yeah, Hiba is here now.
Sorry, sir.
What is going on in your class? स्कूल में?
Sir, we started hello alkenes.
अच्छा हेलो अल्किन, यानी कि हमजा आपके भी क्लास में वही होने वाला है ना?
यस सर।
ओके ठीक है, तब तो ये सही है कि हम हेलो अल्किन ही. अच्छा, so azeotrope. Okay, so there are some azeotrope. What will happen? They will boil at a higher temperature than both the components, right? They boil at a higher temperature than both the components. Okay, now those who boil at a higher temperature than both the components, these will be known as maximum boiling azeotrope. Maximum boiling azeotropes. There will be some which will boil at a lower temperature than both the components. Boils at lower temperature than both the components. Okay, and this will be known as minimum boiling azeotrope. Minimum boiling azeotropes. Okay, now those which boil at a higher temperature, that means they require high energy in order to break the intermolecular forces of attraction. That means their intermolecular forces of attraction are higher. It means that they will be showing negative deviation from Ransdorff. The intermolecular force of attraction high here, it means the vapor pressure is low. The vapor pressure is low, and that is why these are formed by formed by solutions showing negative deviation from Rod's law. And these are formed by solutions showing positive deviation from Rod's law. Please raise your hand if you're done. Aisha, Hamza, and Hiba waiting for you guys. Okay. I write this question. After that, write this one. Tell me answer in chat, okay? A or B? You're saying a solution containing components A and B, it follows Rawls' law. That means it obeys Rawls' law. Okay, Kulsum. Okay, that is for 27. Okay, Hamza. Okay, Akshay. Okay, Mansi. Yes, Nita. Okay, waiting for Hiba, Krishna. Who else has not given the answer? Okay, Aisha has given the answer. Yes, Hiba. Okay. Krishna से नहीं आया answer ना? Yeah, Krishna hasn't answered. Who else? I think everyone answered. Yes, Krishna.
Yes, I was writing the question. 1 second. Sir.
Ryle, Rachita. Writing the question. Okay, Nita. Okay. So the 27th question, the solution that okay. So let us see here. A solution that containing components A and B, which follows Rawls law. Okay. That means it will follow the Rawls law, that is P total will be equal to P naught A chi A, which is plus P naught B chi B. Now, first option is AB attraction force is greater than AA and BB. So this will be wrong. If AB force of attraction will be greater, then what will happen? Force of attraction is higher. That means less and lesser vapor will be formed. That means P total will be lesser. This is A, and now they are saying that it will follow. That means it should be equal, right? So AB force is less than AA. That means again it is wrong. Why this is wrong? Because if the attraction force is less, that means more and more pressure will be formed, more and more vapor will be formed, and the P total should be higher. But this is not the case because it follows the Rawls law. The last case is AB. So the C case is AB attraction remains same as A and BB. So this is right. C is right. Let us also look at the D option here. Volume of solution is different from the sum of. Now this is wrong. Why? It is saying that the volume of solution, it is not equal to V1 plus V2. Why it will not be equal to V1 plus V2 if the attraction is same? If the attraction is same, then what is going to happen? If the attraction is same, that means the molecules will be occupying the same intermolecular distance, right? The molecules will be having the same intermolecular distance amongst each other in their own individual components as well as in the solution. That is why this fourth option is also wrong. Okay. Now let us look at the next question. Krishna, आपने ये कैसे गलती कर दिया? Yes, Krishna.
No, sir, I didn't pay attention. I thought it was same from the sum of the volume.
अच्छा, यहाँ पे आपने same समझा. Okay. Now next is mixture that forms maximum boiling azeotrope. Okay. Now let us look at the first option here, water and nitric acid, right? So water is H2O. So water will also form hydrogen bonding, right? And nitric also will also form hydrogen bond. Okay. And what will happen if you see nitric acid? Here we have water, which is, so let us make nitric acid. So nitric acid is nitrogen. There is a double bond oxygen. Then there is a dative bond of oxygen like this, coordinate bond, and there is OH. This is HNO3. Now, obviously, there will be hydrogen bonding here, but as soon as I will add water here, what will happen? We can have further more hydrogen bondings like this. Now, this hydrogen bonding is very much stable. One of the reasons is because it is hydrogen bonding. There are two new hydrogen bonding which are being formed. Also, the one, it is kind of making a cyclic ring. It is kind of making a cyclic ring that is more and more stable. That is way more stable. Okay. But the main reason is because of the formation of new hydrogen bonds. There will be increase in intermolecular force of attraction. If there is increase in intermolecular force of attraction, that means it will take higher temperature to boil. The boiling point will increase, and that is why it will be forming maximum boiling azeotrope. Now let us look at the other option, why they are not forming maximum boiling azeotrope. Why they are not forming maximum boiling azeotrope? So if I look at ethanol and water, ethanol is having hydrogen bond. Water is also having hydrogen bond. Okay. Now, obviously, all the ethanol molecules C2H5OH, right? And HOO. Sorry, not HO, OHH. Okay. OHH. Now, none of the oxygen is free here, right? Both of the oxygen are bonded to already some hydrogens. So you don't have any free oxygen which can form new hydrogen bondings, right? It cannot form new hydrogen bonding. That's right. This will be almost like, this will be not forming a maximum boiling azeotrope. Rather, if I add water to if I add ethanol to water, what will happen? Some of the hydrogen bonding of water will be disturbed. And since water can form two hydrogen bonding, ethanol can form only one hydrogen bonding, intermolecular force of attraction will decrease rather, not also, it will never increase. Now acetone is what? Acetone is polar. Carbon disulfide is non-polar, right? Because the polarity is cancelled. Polarity is cancelled. Now in acetone, if I add something which is non-polar, what it is going to do? It is going to decrease the intermolecular force of attraction. It is going to decrease the intermolecular force of attraction. Now heptane and octane, heptane will be non-polar, octane will be non-polar, and this will be almost making an ideal solution. That is why all of these three options are wrong. The only option which is going to make a maximum boiling isotrope will be the first option, that is A, with water and nitric acid. Due to the availability of free oxygen in nitric acid, there will be a large number of new hydrogen bonds that will be formed and the intermolecular force of attraction will increase. Is that right? Yes or no? Please tell me. All of you understood why A?
Yes, sir.
Yes.
Okay. Okay. Now, after azeotrope, we have the next topic, which is colligative properties. Please write the topic. Colligative properties. Now, what are colligative properties? Colligative properties are those properties which depend only on the number of solute particles, only on the number of solute particles. Now, let me give you an example. We have till now seen two laws, Henry's law and Raoult's law. Henry's law says that pressure is equal to, don't write anything, please listen, KH into, what is Henry's law? Tell me. What is Henry's law? Pressure is equal to KH
KH into XG.
chi B. KH into chi B. Achha, what is Raoult's law? P total is equal to? P total is equal to?
P naught A chi A
P naught A chi A
plus P naught B chi B.
plus P naught B chi B. Okay. Now, in both the cases, you can see that it depends on chi B, right? Chi A and chi B. That means it depends on the amount of solute, obviously, but it also depends on KH. What is KH? KH is the vapor pressure, right? KH is the Henry's constant, right? KH is the Henry's constant, and here it depends on P naught A and it depends on P naught B. Now, P naught A and P naught B, what does it mean? It means the vapor pressure of pure solvent, the vapor pressure of pure B. That means it also depends on what is A and what is B. It depends on the how much is A, how much is B, but it also depends on what is A and what is B. Because if we have water and ethanol, the P naught A, P naught B will be different. But if we have heptane and octane, the P naught A and P naught B will be different. Now, colligative properties are those in which you will not require anything which depends on the solute. Anything which depends on the solute, you will only require the amount of solute, not the nature of solute. Only require the amount of solute, not the nature of solute. Okay, so please write with me. The properties of solution which depends only on the number of solute particles and not the nature of solute are called colligative properties. Okay. These are also known as democratic properties. These are also known as democratic properties. That means only number matters. Nature doesn't matter. What matters here? Only number. So there are 4 colligative properties that we will be studying. There are 4 colligative properties. There are 4 colligative properties. Number 1 is relative lowering of vapor pressure. Relative lowering of vapor pressure. RLVP. Second is elevation in boiling point. Third is depression in freezing point. And the last is osmotic pressure. This is osmotic pressure. Please write this down. Let me know when you're done. Then we'll start with relative lowering of vapor pressure. All of you understood this point, yes or no? Why it is known as democratic properties? Yes or no, guys?
Yes,
Please
sir,
tell me.
Yes.
Right now? Okay. Done, guys? Let me know when you're done. Let me know when you are not done. Okay. किसी ने नहीं लिखा तो please बता दीजिएगा. Now listen. You won't write, okay? We were learning about solutions. Until now, we have saw solutions in which we can add liquid and gas, in which the solvent is liquid and we have added gas. Okay. Then we have also seen liquid plus liquid, in which the solvent and the solute both are liquids. And then we will also talk about liquid, in which we have added solids. Now, if I have liquid and gas, please tell me, okay? Don't write anything. Please tell me if I have liquid and gas, and if I want to measure the vapor pressure here, if I want to measure the vapor pressure, most of these vapors will be due to which has the most escaping power, liquid or gas, which will escape easily, liquid or gas?
Gas.
Gas. All of you agree with gas, right? That is why whenever we have liquid and gas, we apply the Henry's law. And the Henry's law says what? Pressure is equal to KH into chi V. It doesn't even talk about the liquid. It doesn't even talk about the solvent, because most pressure, that means most of the vapors that will be present, will be due to gas, because gas easily escapes. Gas escapes easily. But when we have liquid plus liquid, what is going to happen? If I have A and B, in this case, the P total, it will depend on both A and B, which will be equal to the P naught of A chi A, P naught of A chi A plus P naught of B chi B. Good. You guys got it, yes or no? Now it will depend on both A and both B, because liquid and liquid, both of them can evaporate. Yes or no?
Yes, sir.
Yes, sir.
Now, if I look at liquid plus solid, tell me what will evaporate here? Which will evaporate easily? Which will
Liquid.
escape easily? Liquid will escape easily, right? Liquid will escape easily. Now, if liquid will escape easily, then can I say that the P total, that means or the P solution, whatever we are having of this solution will be directly proportional to the mole fraction of A? Yes or no? It will depend on the mole fraction of A, correct?
Yes.
If we have more liquid, that means the vapors will be easily forming. If we have less liquid and we have added too much of solid, that means the vapor will be forming in a very minute amount. That means P total will be equal to P naught A chi A. Correct? Yes or no? Please tell me.
Yes, sir.
Yes, and now we can start writing about relative lowering of vapor pressure. Okay, please write with me. Relative lowering of vapor pressure. Relative lowering of vapor pressure. So what is relative lowering of vapor pressure? When a non-volatile solute, when a non-volatile solute is added, मतलब कि dissolved liquid is dissolved in a solvent, vapor pressure of solution becomes lower than that of pure solvent. This is known as RLVP, relative lowering of vapor pressure. Okay. Obviously, if we have pure solvent, if you have just liquid, it will have higher vapor pressure. But if I add some solid, what will happen? The vapor pressure will decrease. That is the relative lowering of vapor pressure. Now we will try to derive the equation or expression for relative lowering of vapor pressure. Let me know if you're done. So I think you guys are done. Please listen, okay? Please listen. In a solution of non-volatile, see, non-volatile is just a CBSE way of telling solid. Okay, it means solid. Non-volatile solute. Non-volatile का मतलब क्या? At room temperature, it does not give me any vapor. That is non-volatile. So in a solution of non-volatile solute, the P total, you may also see that this is also somewhere written as PS. Okay, PS का मतलब P solution है ना? We are writing it P total because Rawls law में भी हमने वही लिखा था. NCERT में आप देखिएगा तो वो PS लिखा हुआ, that is P solution. Same thing. P total will be equal to P naught A chi A. Now we can also write this as P naught A into 1 minus chi of B. Why? Because chi A plus chi B is equal to 1, which implies that chi A will be equal to 1 minus chi B. Then I can further write this as, this is P total, P naught A minus P naught A chi B, P naught A chi B. Now, here if I want to write the difference between the P total, then we can write P naught of A minus P total will be equal to P naught of A chi B. Now, this is the difference in the vapor pressure of solvent and solution. This expression is known as lowering of vapor pressure This expression is known as lowering of vapor pressure. Okay, lowering of the vapor pressure. Now, when I divide this by P naught A, that means I am getting a ratio of the difference and P naught A, right? How much is lowered per P naught A? How much is lowered per P naught A? That means P naught A minus P total. That is the difference that has been lowered, divided by P naught of A is equal to chi B. Is equal to chi B. This expression is known as relative lowering of vapor pressure, RLVP. This expression, P naught A minus P total is P naught A minus P total upon P naught A is equal to chi B. Is equal to chi B. You may also see somewhere it has been written as delta P. It has been written as delta P upon P naught of A is equal to chi B. Delta P means the difference in the pressure, the difference in pressure. Now of solvent and solute. I will also write here what is P naught A is the vapor pressure of pure solvent. PA is vapor pressure of solution. Chi B is mole fraction of solute. So please write this down. Let me know when you're done. Raise your hand if you're done, guys. Okay, only Krishna is done. Others write fast. Kulsum is done. Okay, fine. So I think everyone is done, right? Mansi, Hamza, Hiba.
1 minute, sir.
1 minute.
Done, sir.
Done. Okay. What about Hamza and Hiba? Hamza का हो गया. Hiba, what about you? लिख लिया आपने?
Yes, sir, done.
Okay. So let us also write the 1 point determination of molar mass of solute using RLVP. Okay, so this is quite simple. Now this is only for dilute solution. Okay, please remember that only for dilute solutions. Now you all know what is RLVP, relative lowering of vapor pressure. It is equal to P naught of A minus P total. P naught of A minus P total upon P naught of A upon P naught of A, which will be equal to chi B, mole fraction of B. Now chi B will be equal to number of moles of B upon number of moles of A plus number of moles of B. As we have said, for dilute solution, what will happen? Number of moles of A will be very, very, very greater than number of moles of B. And in that case, we can neglect this B. So it will tell P naught of A minus P total upon P naught of A will be equal to number of moles of B upon the number of moles of A. Okay, please listen here very carefully. Don't write anything else. Please don't write anything. We can write number of moles of B as what? Number of moles of B as the given mass upon the molar mass of B. Number of moles of A I can write as given mass of A divided by molar mass of A. And hence we can write from here the P naught A minus P total upon P naught A, it will be equal to WB upon MB into MA upon WA. Suppose समझ में आया ऐसा ना, please tell me.
Yes, sir.
Okay.
Yes.
Now see, please listen here. Okay, please listen here. Let us suppose you have a container in which you have water. Okay, and you have been given something B, some sample B. Okay, so some sample B is 5 gram you have been given. So what you do, you add 5 gram of B into water. You add 5 gram of B into water. Let us say, suppose in 1 liter of water. Okay, and then what you do, you measure the P total here, because ये क्या होगा, the pressure of solution, the vapor pressure of solution, that will be P total. Now P total you have got, P total you have measured. P naught of A is what? You can check from data booklet, right? If you have water, what is the vapor pressure of pure water? You got these 2 points, yes or no? Please tell me. P total you can measure, P naught A from the data. Then WB, that means the mass of B that you have 5 gram जो भी लिया आपने, you just need a simple electric balance, in that you can measure it. Then what do you need? The W of A, the amount of water that you are taking, you should know, because you are taking that much amount of water. So you can also measure it. Molar mass of A, if it is water, if you know what is the solvent, you can easily know what is the molar mass, right? So you will know this. The only thing that is remaining is the MB. And if you just rearrange this, you can solve for MB, linear equation in one variable. So we'll write MB is equal to the molar mass of B. It will be equal to WB into MA, WB into MA upon WA into P naught of A upon P naught of A minus P total. Now, if you see this very simple experiment in which we are adding very small amount of solute, small amount of solute, and we are measuring the difference in pressure, and that is telling me about the molar mass of that particular solute. If you don't know, if something unknown is given, some sample is given to you, and you have to predict and you have to calculate the molar mass, this is a very simple way in which you can determine the molar mass of a solute. Is that clear? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
See, the usability is also very important. You should know what is the usability here. Please write this down. MB is equal to WB into MA upon WA into P naught A upon minus P naught A minus P total. Okay, and now here I will write what are these things. First of all, MB is molar mass of, what is MB? Molar mass of
Solute.
solute. Then comes WB. WB is the mass of solute in solution. Next we have MA, molar mass of solvent. Then we have WA, mass of solvent. P naught A, vapor pressure of pure solvent, P total, vapor pressure of solution. Chalo, please write this down. Let me know when you're done. Then we will do one question here. Okay. अक्षय, आपका केमिस्ट्री का एग्जाम हो गया क्या? मैथ्स का आप कह रहे हैं मंडे को?
So not exam, class test.
क्लास टेस्ट कौन सा चैप्टर आ रहा है मैथ्स में?
Max derivatives. No, sorry. Determinants. Sorry. Determinants.
डिटर्मिनेंट्स ना, डेरिवेटिव्स तो नहीं है उसमें ना, 12th में नहीं है, 11th में डेरिवेटिव्स, राइट? हाँ,
So we have derivatives on this continuity chapter.
हाँ, लाइक उसमें है यार. ओके फाइन, कंटिन्यूटी में है. इवन आई थिंक डिफरेंशियल इक्वेशन भी शायद 12th में है ना.
I don't know about that, sir.
डिफरेंशियल इक्वेशन पता आपको? डिफरेंशियल इक्वेशन है 11th में ही नहीं है तो 10th में था, सॉरी 12th में होगा. अच्छा, बाय द वे मैथ्स में कौन सा चैप्टर हटाया फिर? हाँ अक्षय, डू यू नो व्हिच चैप्टर हैज बीन रिमूव्ड फ्रॉम मैथ्स?
No, sir. I don't.
डोंट नो. ओके, केमिस्ट्री का पता है अक्षय?
Chemistry. I think the first chapter is not.
फर्स्ट चैप्टर इज नॉट देयर
Uh,
and the last chapter is not there. Okay, I think there is one more
Okay.
chapter which has been removed, which is there are S block, P block has also been removed. Chemistry में सब बहुत ज़्यादा reduction. That I think so. हमने देखा नहीं physics और इसमें. Does anyone know maths में कौन सा chapter हटाया गया है? I think there is one chapter LPP, linear probability, ऐसे एक chapter था शायद 12th में. That must have been removed. LPP, linear programming करके कुछ था. Nobody knows. Krishna, Hamza.
So we have not been informed in the project.
So you haven't been informed. Physics में? नहीं पता physics में भी. Okay. चलिए. So all of you have written this. And I write a question. A solution is prepared by dissolving. I'll write the question. A solution is prepared by dissolving. Solution is prepared by dissolving 10 gram of non-volatile, 10 grams of non-volatile, 10 grams of non-volatile solute in 200 grams of in 200 grams of water. 200 grams of water. It has a vapor pressure of of 31.84 mmHg. It has a vapor pressure of 38.14. That means it means solution. The solution has a vapor pressure of 31.84 mmHg at 308 Kelvin. We have to calculate the molar mass of solute. The vapor pressure of water, it has been given as vapor pressure of pure water is equal to 32 mm of Hg. Solve this question. सिंपल फॉर्मूला बेस्ड, अभी जो हमने कराया बिल्कुल वैसे ही है. whatever formula we have just written, just apply that formula, plug in the values, that is it. Who will tell me the formula? MB is equal to molar mass of solute is equal to what? Tell me. Look at your notebook and tell me na. MB is equal to
So WB into MA by WA into P naught A by P naught A minus P total.
WB into MA upon. Please can all of you tell me? Can all of you turn the mic on? Tell me. Yes, Mansi, Hamza, Hiba, Kulsum, Nida. WB into MA upon
WB into MA upon
WA into
P naught A by P
into
naught A minus P total.
minus P total. कृष्णा फिर से कैलकुलेट कीजिए. कुलसुम and Akshay correct. Krishna, see you're missing somewhere in the you're missing somewhere in the calculation. WB is equal to how much? Now it is correct, Krishna. So I think अच्छा कितने लोगों ने आंसर किया अभी तक? कृष्णा, कुलसुम, अक्षय. Okay, waiting for others. हाँ, हमजा का सही है जवाब. जो लोग बहुत ज्यादा कैलकुलेशन कर रहे हैं ना, देखिए इधर. इट वाज अ इजी क्वेश्चन. ओके, लुक हियर. WB is how much? Tell me, मानसी. WB कितना है मानसी? 10. Very good. MA, molar mass of solvent, molar mass of water is equal to how much? वाटर का मोलर मास कितना होता है?
0.95.
नहीं, कितना बोला मानसी आपने? सॉरी,
We got 0.95.
0.95 मोलर मास फॉर वाटर.
It's 18.
हाँ, इट्स 18. ओके मानसी, देखिए हाइड्रोजन का कितना होता है? 1. सो देयर आर 2 हाइड्रोजन्स, यू मल्टीप्लाई 2 हियर. ओके, एंड देयर इज 1 ऑक्सीजन. एंड ऑक्सीजन का कितना होता है बताइए? 16.
I calculated the
Right.
wrong thing.
यू कैलकुलेटेड द रॉन्ग थिंग ओनली.
Yes.
अरे क्यों, कैसे? चलिए ठीक से कैलकुलेट कीजिए. आई हैव रिटन द फॉर्मूला हियर. 10 here, molar mass of A solvent will be equal to how much? 18 grams per mole. WA is equal to how much? 200 grams into P naught of A is 32 divided by P naught of A is 32 minus P total, which is 31.84. Right? So this will be equal to, don't do anything, okay? 10 into 18 into 32 divided by 200 into 32 minus 31.84. This will give you 0.16. Okay, now see here, I can write this as 10 into, प्लीज मानसी आप देखिए, जिन लोगों ने अभी तक आंसर नहीं दिया प्लीज वो लोग देखिए, इनको हम कैसे लिखेंगे? 2 into 100 into 6, 0.16. ठीक है, अब देखिए 0.16 into 100 will be 16, and 16 to the 32. So this will be 10 into 18 into 32 divided by 32. तो ये आपका कट के आ जाएगा 180 grams per mole. Got it? Yes or no? Please tell me. Got this? अरे हाँ या ना तो बोलिए.
Yes, sir.
मानसी,
Yes.
निदा आपने जवाब दिया था. निदा ने भी आंसर नहीं दिया था. व्हाट हैपेंड निदा? निदा,
I was calculating.
यू आर कैलकुलेटिंग. आप इसको मल्टीप्लाई कर दिए क्या?
No. हाँ.
नहीं, तो वैसे नहीं कीजिएगा. देखिए, लेट मी टेल यू वन थिंग. जब भी मल्टीप्लिकेशन करना होगा ना, बिल्कुल आखिरी में कीजिएगा. ओके, सी, यू हैव टू सॉल्व दिस वन, राइट? यू हैव टू सॉल्व दिस पार्ट. इसको पहले सॉल्व कीजिए. जो छोटे छोटे चीज है ना, सब मल्टीप्लिकेशन से पहले सब्ट्रैक्शन एडिशन जो है उन सबको कर लिया कीजिए जो छोटे छोटे होते हैं, ठीक है। और सो वन मोर थिंग, दिस विल बी इन ब्रैकेट्स ओनली, ओके। चलिए नेक्स्ट इज, अच्छा वी आल्सो हैव टू लुक एट द ग्राफ फॉर, ये तो आप लोगों को जल्दी समझ में आ जाएगा, ग्राफ फॉर RLVP, relative lowering of vapor pressure, okay, relative lowering of vapor pressure। इसमें क्या होगा, so in this graph we will be plotting pressure and mole fraction of A। So we all know at this point chi A will be equal to how much, tell me? Chi A will be equal to
0.
0, chi B will be equal to 1। now this chi B is what, it is a solid will have no vapor pressure, so the starting point will be here only, and we know at this point chi A will be equal to 1 and chi B will be equal to 0, so this is the point where we have pure A, and hence the vapor pressure will be equal to P naught of A, right? Vapor pressure will be equal to P naught of A, so this point will be P naught of A। so we are starting with 0, and as we increase the chi A, the pressure will also increase and it will reach P naught of A eventually, ठीक है। so please write this down very fast, graph for relative lowering of vapor pressure। Write fast guys, graph for relative lowering of vapor pressure। okay, चलिए moving on। now all of you will tell me, we have let us say as pure solvent, okay, pure solvent A, and then we have added something, and this is we have solution here, we have here solution, and here we have pure solvent। now whose vapor pressure will be higher, pure solvent का या solution का? this is having a solid solute। अभी हमने क्या पढ़ा, tell me, whose vapor pressure will be higher, solvent or solution?
Solvent.
Solvent will be higher, so let us say that the vapor pressure here is 0.5 atm, and let's suppose the solution vapor pressure is 0.2 atm, and I have to boil them, now in order to boil, whether it is pure solvent A or whether it is the solution, we need to reach that atmospheric pressure, right? we need to reach the vapor pressure which will be equal to 1 atm, है ना? we have to increase the vapor pressure from 0.5 atm to 1 atm, and we have to also increase the vapor pressure from 0.2 atm to 1 atm। now in this case you will tell me which will require a higher temperature, कहां से कहां जाना मुश्किल है, and which will require a higher temperature from 0.5 to 1 atm or 0.2 to 1 atm, tell me which will require a higher boiling point, higher temperature to boil, higher temperature to 0.2, है ना? so we can say that when we add a solute which is solid, which is non-volatile, it increases the boiling point, right? so this is known as elevation in boiling point। सबको आया समझ में? yes or no, please tell me this part,
Yes, sir.
Yes, sir.
Yes,
all
sir.
of you got this now, है ना? चलिए, so we'll write this now, elevation in boiling point। the next colligative property, elevation in boiling point, okay, elevation in boiling point। so first of all, what is boiling point? boiling point is the temperature at which vapor pressure at which vapor pressure of a liquid is equal to vapor pressure of a liquid is equal to the atmospheric pressure. The atmospheric pressure. Okay. Now let us see what happens if we have a non-volatile solute. We all know the vapor pressure of a solution with non-volatile solute decreases, right? What happens? It decreases and is always lower than pure solvent. It is lower than pure solvent. And that is why what will happen? Hence, the solution would require a higher temperature to boil. It would require a higher temperature let us write to reach a vapor pressure of 1 in atm and eventually boil. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. You can also write one more point like this. If you have a container like this, in which you have pure solvent, okay? And in this case, we have added some solute here. So as you can see, some of the solute particle is taking the surface, taking some space in the surface, and that is why it will not allow the liquid to boil. It will not allow the liquid to convert into vapor because it is present in the surface. It will be hindering the conversion of liquid to vapor. It will be hindering the conversion of liquid to vapor, and hence it will not let it reach the boiling point easily. It will require a higher temperature to reach boiling point. Okay. Also write one more point here. A solid solute would acquire some space in the surface of solution. It will hinder the conversion of liquid to vapor. Can you please write this down? Let me know when you're done. Done all of you? Yes or no? Please tell me.
Yes, sir.
Okay. Right. Next graph for elevation in boiling point. ठीक है? Please listen. Don't write anything. Okay? Please listen. Don't write anything. ध्यान से सुनिएगा. It's very important. You have to understand this in one part only. Okay? So here we will be plotting vapor pressure against temperature, and temperature will be in Kelvin. Okay? Temperature will be in Kelvin. Now, since it is about boiling point, a very important pressure is the pressure that is equal to 1 atm, है ना? The pressure that is equal to 1 atm. So we'll mark that point. This is the 1 atm pressure. Okay. ये y-axis वाला point है. This line doesn't mean anything. It is. I am plotting here. ये सारे points क्या बता रहे हैं? All of these points are having 1 atm as the pressure. Okay. As y-axis. In y-axis you have 1 atm pressure. Now, please listen very carefully. Let us start with a solvent. Let us start with a solvent. And obviously at room temperature it will be not boiling. It will be having some. Vapor pressure which is lower than 1 atm, Now, what we'll be doing, we will be increasing the temperature slowly. As we increase the temperature, the vapor pressure will increase and reach 1 atm. At this point, what will happen? It will start to boil. Say that, okay, fine. The temperature at which it is boiling is equal to this is the temperature at which the solvent is boiling, the pure solvent. Now, the vapor pressure of solution will be greater than solvent or lower than solvent. It will be higher or lower, higher than solvent or lower than solvent. Solution का vapor pressure क्या होगा?
Lower than solvent.
Lower than. तो यहाँ से start करते हैं हम लोग lower than solvent. And then what we'll do? We will start to increase the temperature like this. And it will reach the boiling point at here. समझ में आ रहा है ना यहाँ पे क्यों? Yes or no? Because this is the vapor pressure where it is 1 atm. ठीक है? When the vapor pressure is 1 atm, then it starts to boiling. And then it will just drop a perpendicular line on the x-axis. And you will get the temperature here. Okay. So we can say 2 points. We can say that first thing that this is the boiling point of pure solvent T0B. Okay. And this is the boiling point of solution, which is TB. Just TB. So please write with me now. अब लिखिए ग्राफ को बनाइए आराम से, ठीक है? उसके बाद ये पॉइंट्स लिख लीजिएगा. T0B क्या है? Boiling point of pure solvent. TB क्या है? Boiling point of solution. We can see that TB is greater than T0B. ठीक है? तो जो elevation in boiling point होता है उसको लिखते हैं लोग delta TB. The difference in boiling point will be equal to what? Will be equal to the boiling point of solution minus the boiling point of pure solvent. ठीक है? Minus the boiling point of pure solvent. कितना लिख के बताइए सबका हुआ या नहीं? Raise your hand if you're done. Okay. So I think most of you are done. Now please tell me now. अब एक बात बताइए आप लोग. Can I say that the elevation in boiling point will increase if I add more and more solute? If I will add more and more solute, what will happen? The vapor pressure will come further down, and it will be requiring, the solution will be requiring a higher temperature to boil. Yes or no? Please tell me.
Yes, sir.
Got it, all of you? Yes or no? Hamza, Heba,
Yes, sir.
Kulsu,
Can you please repeat?
that means the elevation in, I'm saying if I increase the amount of solute, okay, then what will happen to the vapor pressure? It will decrease or increase. If I add a solute, solid solute, then what will happen to the vapor pressure? Increase करेगा या decrease करेगा? Yes, मानसी? आराम सोच के बताइए, थोड़ा जोर से ही बोलिए, ठीक है? आवाज नहीं आ रही आपकी. सॉलिड कैसा, आपका सॉल्यूट कैसा है? सॉलिड है, लिक्विड है, वेपर है? सॉलिड है, लिक्विड है या गैस है? हाँ मानसी, जोर से, आवाज ही नहीं आई. सॉलिड. तो सॉलिड का वेपर होता है क्या? तो उसका वेपर प्रेशर होगा? हाँ, व्हाट आर यू सेइंग? आवाज नहीं आ रही आप ठीक से. कैन समबडी टेल मी व्हाट मानसी इज सेइंग?
It will decrease.
इट विल डिक्रीज. ओके, ठीक है, आप एकदम झटके में बोल देती हैं लगता है. इट विल डिक्रीज, राइट? इफ द वेपर प्रेशर विल डिक्रीज, दैट मींस वी हैव टू पुट मोर टेम्परेचर in order to reach the boiling point.
Yes.
है ना? यानी कि जो एलिवेशन इन बॉइलिंग पॉइंट है, जो डिफरेंस होगा बॉइलिंग पॉइंट का, दैट विल बी डायरेक्टली प्रोपोर्शनल टू द कंसंट्रेशन ऑफ सोल्यूट. And since it is directly proportional to concentration of solute, now what concentration terms matches the concentration terms which matches the data, experimental data, that is molality. Delta TB, we say that it is directly proportional to molality. Okay, M. Now, in order to remove this proportionality sign, we'll say delta TB is equal to KB into M, which is the molality. KB into M, which is the molality. So what is this delta TB? This is equal to TB minus T naught B. What is this M? M is molality. And this KB is molal elevation constant. It is also known as, और एक क्या नाम है इसका? Boiling point elevation constant. Elevation constant. There is one more name for this. The other name for this is ebullioscopic constant. Ebullioscopic constant. Okay, so let us write one more point for molar elevation constant. So what is molar elevation constant? It is KB. All know that delta TB is equal to KB into M. So KB will be equal to delta TB upon molality. So delta TB, its unit is in Kelvin because it is temperature. Molality is mole per kg. So what will happen to KB? So the KB's unit will be equal to how much? Mole per kg will go above and it will become Kelvin kg per mole. Kg inverse will go above and it will become kg. Mole will go above and it will become mole inverse. Also, for a 1 molar solution for a 1 molar solution, we can write delta TB is equal to KB. डेल्टा टीबी क्या है हमारा? एलिवेशन इन बॉइलिंग पॉइंट है ना, एलिवेशन इन बॉइलिंग पॉइंट. ठीक है, सो वी कैन राइट व्हाट इज द डेफिनेशन ऑफ केबी. वी कैन राइट केबी इज द elevation in boiling point when the concentration of solution is 1 molar. 1 molar mean 1 molar means 1 mole per kg. सबका हो गया ये सर? नो प्लीज टेल मी.
Yes, sir.
Yes, sir.
जस्ट वेट अ सेकंड. चलिए एक ये लिख लीजिए बस, है ना, डिटरमिनेशन ऑफ we'll write just write the formula. Mass determination of molar mass using delta TB. ठीक है, so we know that delta TB is equal to KB into M, right? And what is M? M is equal to number of moles of solute divided by the mass of solvent in kg. And what is NB? Number of moles of solute is equal to the given mass upon molar mass. This is the molar mass that we need. So we can just write this is equal to KB into molality will be equal to how much? WB by upon MB, WB upon MB, ठीक है, upon WA in kg. So we can write this as KB into WB upon MB into WA in kg. ठीक है, WA in kg. Now अब यहाँ पे ये क्या डेल्टा टीबी है, MB को उधर ले जाते तो दिस विल बी इक्वल टू MB दैट इज इक्वल टू KB into WB upon delta TB into WA in kg, है ना, WA in kg. ठीक है, अब इसी को क्या लिख सकते हैं आप लोग? KB into WB into 1000 upon delta TB into WA, है ना. And now here you can write everything in grams. Done all of you, Sonu, please tell me.
Done, sir.
Okay, chalo. Thank you very much. That's it for today. Okay, we'll meet tomorrow. And assignment में आपके पास इसके ऊपर सवाल होंगे elevation boiling point के ऊपर. But we will also do some questions in tomorrow's class. Okay, we'll do some questions on tomorrow's class. हाँ बताइए.
When you go to the Learnivio website, it shows your subscription has expired.
What, Mansi? Can you please repeat yourself?
I'm not able to see any of the assignments because when you go to the site, it shows your subscription has expired.
Subscription is expired. Your submission date is expired.
No, it shows subscription.
Subscription is expired. Okay. तो फिर आपको मैसेज करना पड़ेगा Learnivio को.
Okay, sir.
Okay. अच्छा, one more thing for all of you. Please revise these topics. You have to revise Henry's law and Rawls law. Okay, these two topics. Tomorrow I will be asking you some questions on Henry's law and Rawls law. Also, Rawls law के अंदर ही क्या जाएगा आपका ideal and non-ideal. Okay, I will giving you questions on these three topics tomorrow. So for around half an hour, I will be revising these topics. Okay, then only we will start with class. Okay, so tomorrow half an hour. Okay, these topics. मानसी आप याद से कर लीजिएगा, ठीक है मैसेज Learnivio को.
Okay, sir.
ठीक है. अक्षय आप कुछ बोलना चाह रहे थे?
No, sir, no, nothing.
Nothing? अच्छा चलो.